Take a look at the technology surrounding you right now. The overhead lighting, the motors in your appliances, the wireless data reaching your phone. The existence of these tools is tied directly to the master plan of a single inventor. When Nikola Tesla arrived in New York in 1884, he was a penniless immigrant. He relied entirely on his mathematical calculations and a photographic memory that allowed him to visualize complete, complex machines in his mind before he ever touched a tool. At the time, Thomas Edison's direct current system was the industry standard. But the DC grid was stalled by a massive physical limitation. Direct current loses strength rapidly over distance, requiring power stations on nearly every block. Tesla's solution was alternating current, or AC. By stepping voltage up for long-distance travel, then back down for safe home use, AC power reached distant customers without energy loss. Tesla wasn't looking to fix a local neighborhood's lighting problems. He had architected the first mathematical framework capable of wiring the entire planet. For the AC system to be practical, it needed to do more than just power light bulbs. Tesla developed the induction motor, a breakthrough that allowed alternating current to drive the heavy machinery required by modern industry. Engineering requires capital. Tesla partnered with George Westinghouse, an industrialist with the resources to manufacture these motors and challenge Edison's monopoly over American power. This ignited the War of the Currents, a brutal commercial and ideological fight to decide the very nature of the nation's electrical infrastructure. The turning point came in 1895 at Niagara Falls. The project aimed to harness the kinetic energy of that massive volume of water into electricity. The project worked perfectly. Tesla's AC system successfully captured the power of the falls and transmitted it over 20 miles away to Buffalo, New York. The success at Niagara proved that AC was the only system capable of scaling to meet the energy demands of a modern nation, turning Tesla's design into the template for the global grid. Once the wired grid was a proven reality, Tesla shifted his attention toward a world where wires were no longer necessary. In 1891, he invented the Tesla Coil. This device generated the high-voltage, high-frequency electricity needed to transmit energy wirelessly through the air. Tesla used these high frequencies to pioneer radio wave technology, culminating in a public demonstration where he used wireless signals to navigate a remote-controlled boat. Based on these experiments, he predicted a future defined by a global wireless internet, automated factories, and handheld devices that could communicate instantly across the world. These weren't guesses, they were calculated engineering forecasts. Having already prototyped the physics of wireless data and remote automation, Tesla was describing the inevitable result of his own laboratory work. Tesla's ultimate goal was the Wardenclyffe Tower in New York. This massive structure was designed to act as a hub for a global system that would transmit both information and electrical power wirelessly to every corner of the Earth. But the project never finished. The sheer scale of the tower outpaced the financial appetite of his investors and the technological manufacturing limits of the time. After his financial backers withdrew, the project was abandoned. The tower was eventually sold for scrap and demolished. Tesla's final years were spent in relative solitude. In 1943, he died in a New York City hotel, with very little money to show for his contributions to the world. While the physical tower at Wardenclyffe collapsed, the mathematical blueprint Tesla left behind remained perfectly intact. Tesla's intellectual legacy is massive, comprising over 300 patents that cover mechanical, electrical, and radio engineering. His impact is codified in modern science. Today, the standard unit for magnetic flux density is officially known as the Tesla. Today, his original patents operate the motors in your appliances, the circuits in your phone, and the high-voltage grids lighting every major city on Earth. True visionaries rarely capture the financial rewards of their work, but their ultimate success is architectural. Every time we flip a switch or connect to a network, we are living inside a master plan designed by Nikola Tesla.